Today I will introduce about LoRaWAN architecture. LoRaWAN architecture. LoRaWAN is a low power wide area network technology that enables long range wireless communication for Internet of Things devices. LoRaWAN networks are deployed in a start of topologies. A typical LoRaWAN network consists of the following elements. LoRaWAN comes under MAC layer protocol, which is made for large scale public area network. LoRaWAN is created using stable technologies. LoRaWAN comes under the non-circular wireless communication network protocols. It follows chief spectrum modulus. This is the structure for LoRaWAN network architecture. End nodes, constructor gateway, network server, application server. End server. Sensor or actuator sends LoRa modulate wireless messages to gateways or receives message wireless back from the gateways. Gateways receive message for end device and forward them to the network server. Network server, a piece of software running on a server that manages the entire network. Application server, a piece of software running on a server that is responsible for securely processing application data. Join server, a piece of software running on a server that processing join request messages sent by end devices. The join server is not shown. End devices communication with nearby gateways and each gateway is connected to the network server. LoRaWAN networks can use LoRa based protocol, so end devices don't need to pre with specific gateways. Messages sent from end devices travel through all gateways within range. Those messages are received by the network server. If the network server has received multiple props of the same messages, it keeps a single copy of the messages and discards others. This is known as the message duplications. Let's examine each elements of LoRaWAN networks in detail. End devices. End devices are node devices that serve as a source point or a destination point in the communication that occurs on a computer network. The rest of the network is built around those end devices to establish communication links between them. Software installed on the node devices determines the role they offer to play in computer network. According to their uses, the end devices can be broadly grouped in the following categories. First is end devices as a client, second is devices as server. End devices as a server platform, the task of requesting data, playing received data, etc. meant usually for uses by end clients. End device and servers equipped with a program that provides information and servers such as web page or emails to other nodes or hosts on the network. Functions of end devices, they serve as the originator of the data or information that flows through the network, act as an interface between end users and the communication network having several node devices. This is a structure for end devices. LoRaWAN categorized into three main classes. Class A, Class B, and Class C. With Class A begins mandatory for all devices. Class B and C are optional extensions that offer different rates of between power consumption, latency, and downlink communication. Additionally, LoRaWAN gateways can be classified as indoor or outdoor. Class A, this is the most common and power efficient class suitable for applications where long battery life is circular. Class A devices only have two downlink receives down after each uplink transmission, resulting is non-deterministic downlink latency. Class B. This class adds periodic downlink receives windows, allowing the deterministic downlink latency and reduce power consumption compared to Class C. Class B devices synchronize their clocks with the network server to maintain the downlink windows. And Class C. This class offers the lowest downlink latency by keeping our radio reverse always on, but the cost of higher power consumption. It's suitable for applications require real-time or high frequency downlink communication. Key characteristic of LoRaWAN: long range, long power consumption, server communication, open stands. Application of LoRaWAN: smart cities, industry 4.0, agriculture, healthcare. Smart cities Smart cities is LoRaWAN is used for applications like smart parking, waste management, lighting, and environmental monitoring. Industry 4.0, it is used for industry automation, asset tracking, and remote monitoring of equipment. Agriculture, LoRaWAN enables remote monitoring of soil conditions, irrigation optimization, and other agricultural applications. Healthcare, it can be used for patient monitoring, cloud chain management of various and other applications. Benefits of using LoRaWAN: long range communication is enables communication over distance where other technologies like Wi-Fi or Bluetooth may not be feasible. Long power consumption allows devices to operate for executed periods on battery power, reducing maintenance cost. Scalability: LoRaWAN networks can be scaled to accommodated a large number of devices. Security provides end-to-end encryption to product service data. Thank you.